If you're tuning in, you're probably interested in our guests or their profession, or maybe you're just curious. So let's get on the same page about what forensics engineering means, and then we'll trace back to Matt and Blake's start at Ohio University. Matt, could you start?
Just the basic description of forensic engineering?
Yeah, just super quick.
Sure. I guess the way I sort of summarize it is when we design a new building, it's sort of like the birth of a building. As we maintain a building through its life, it's kind of like going to your primary care physician. And then throughout its life, it may need some specialty care. But forensic engineering is more about when a building needs triage. Something's gone wrong, either in design or construction. There's been a collapse or other failure, or over its time and use, it's degraded to a point where it becomes unstable or unusable. So forensic engineering is looking back into what happened and trying to solve the problem so it doesn't happen again.
Great. Blake, do you have anything to add, any kind of perspective from that?
Pithy response to Matt's really great description. No, I think that's a pretty good one. Forensic is looking back, yeah, exactly, into something that's been designed and built and or is in the process of that, and trying to assess it and make sense of it, as opposed to going forward, right, where you design against something happening. This is looking back to see why did it happen and what does that mean and how do we fix it? Do we need to fix it? It's basically the reverse journey of the design process. No, so that was a good explanation, Matt.
Thank you. So both of you will trace back now to Ohio University. Both of you were engineering students. Did you start out at Ohio University focused on civil engineering? Are you where you thought you'd be when you were a student?
I did, yeah. I wanted to be an engineer for a substantial portion of my life, just as a tinkerer from everything, bicycles, tree forts, cars, renovations, all points in between. So engineering was sort of always on my radar. And so I came to OU to be a civil engineer structural.
Great.
Same to me. I think Matt sounds like he was more of a tinkerer handyman than I was, but I sort of like math and science. I like the outdoor piece. I wanted to do something tangible, right, that I could kind of sense. And civil engineering made the most sense to me to start for that regard, right, in terms of all those things. And I kind of stayed with it. That's right. It was very similar.
Great. And then Blake, you're now in London. You're working for your company.
Yeah.
London office.
Yeah, and I have a slide on my time at Ohio University. If we want to do that, I was looking back at my things I've done in the past. Barbara, can you please let me share my screen?
Yes.
This is a little bit about me, if you will, and let me try it again.
Hang on, here you go.
No worries.
There you go.
Yeah, so you can tell I'm not lying. You've got these incessant buses that go past these windows, and as Kelly was saying, and these windows are pretty, but they're thin and they're loud. So there's goods and bads about all these things. Let's see, where was I going to show? Okay, so hopefully, are we seeing a PowerPoint, Barbara?
Yes, we are.
Okay. So I think I created this several years ago when I went to for another meeting. But yeah, so I did a bachelor's of science at Ohio University. I did a lot of other stuff too, right? And I sort of was just giving. I think one of the things we want to talk about is our connection to Ohio, right? Yes. And so I did all this stuff. It was a lot of fun, right? And that's kind of sort of got me to my track. That was the study side, and there was the fun side, right? I don't know how many other contemporaries there are on this call of the mid 2000s, but as you might remember, this was about the time that smartphones were coming out, right? And I had one of those bricks. And I think that's one of the first pictures ever of me here on the brick phone, where it looks like someone's pouring a pitcher of beer in my lap from, I don't remember which bar it is, courtside, I think, which didn't really happen. But anyway, like everyone probably on this call, I've got a history at Ohio University, and these are a few snippets that I found a little bit ago I thought I'd share. But from there, I went to University of Illinois. I got a graduate degree in structural engineering. I went to Chicago and I joined my company, which is called WJE, and we're a forensic engineering company, if you will, much similar to Matt's company, which he'll tell you about. And And I was there for about 10 years in Chicago, doing structural engineering and some other things. And a couple of years ago, I moved to London to help lead our office here, which is sort of our new a new venture in the UK and Europe. So as you can see, that's where I'm at.
Right. So as a student and you're studying engineering, were you drawn to, as I looked through the websites of both of your companies, there's a huge mix of the preservation, restoration, reusing old buildings, and then also obviously new construction. But were you drawn to that? Was that something you thought about, of having that hand in sort of preserving a historical building? Was there?
I talk last, so I'm just, I'll.
So I'll go first. My entry into civil structural engineering was probably what most people think traditionally of architecture and engineering. So building design, so ground up construction. That always fascinated me. And so I came into the profession, like school and the profession, thinking that I would primarily design new buildings. I'd say that's probably what I've done for 75% of my 20+ year career at this point. And it's over the last 5 or 10 years where I've started to be exposed, because as Blake noted, our firm, about a third of our work is forensic engineering, a third repair and rehab, and about a third new construction. I started to get involved in some of the forensic engineering, where there's small projects, small failures, things weren't performing as intended, and that's grown where it's become a relatively substantial portion of my practice now, evaluating not just building failures, but also claims for underperformance, if you will, by one of the parties in a building construction.
Great.
And for me, I think, how did I get into forensic engineering? I was grad school and I was looking for jobs, and I just beat the recession, the 2008, 2009, which was kind of nice. And looking back, and I happened upon the company I work for now, WJE, at a career fair, and it just kind of made sense, right? It just kind of clicked it just sounded like a neat way to use engineering, to do engineering. And so unlike Matt, I've never really had a new design career. And they're really goods and bad, they're really goods about both. And for my case, I thought this was a good fit, and I think it has ended up being a good fit.
So throughout the different projects that you've both worked on, the WJE has worked on things like the Washington Monument. There's this incredible video of a repeller heading down the Washington Monument to do seismic assessments and things. And then there are other buildings in the portfolio that really push what a modern building looked like. And I wondered if you could just tell me about a project that you really worked on, that you were really honored to work on or proud to be a part of. Something that really sticks out in your mind.
Here you, Matt.
Go ahead, I'll follow you this time. Okay.
Well, there's been a lot of cool projects, and I'm not going to lie, there's been a lot of sort of ordinary projects. I mean, let's not pretend. I mean, we put the cool things on the website, Barbara, right? And those are really, really neat. And I'm proud of our people who've done those. I've done a few cool ones that I think are sort of more monumental. Again, I've done a lot of sort of important but not flashy projects, I would say. And I don't know, I guess I can share one that happened early on in my career. And yet again, I've got another PowerPoint here. So let's see. Hopefully you're looking at some cooling towers now. Does that look right, Barbara?
Yes. Yeah.
This was, this 2012, 13. We did a condition assessment of these concrete cooling towers. And one of the things that I like about the job, which I think is one of the questions, is, perspectives, getting to go to some different places and see some different things, and hanging off buildings in Chicago, which Matt has done and I've done, and these sorts of things. It's one of the things I really like about it, is the perspectives, and so this is a project that highlights that a little bit. We were trying to, as Matt made the doctor's analogy, we were giving this cooling tower a checkup, right? We were trying to assess its health. How's it built? What are the fundamentals? Does it have any deleterious issues? Means, are there any things that it's causing it to get worse. And so we did essentially a checkup, and this was just neat because it's a big structure, right? It's a very interesting structure, and it ends up it's in pretty good shape. And you're just seeing some photos of the things we did, which are you know, some non-intrusive things where you look at the big picture, some intrusive things where you cut core, hammer, and you try to look on the inside and the guts to see how things are performing. And it's just a nice representative project. And, you know, again, from the perspectives thing, it was something I'm not sure I would do again. And I'm trying to get to the photo here, which is to say, you climb this ladder. I'm not sure I'd do it again. It's like 500 feet long ladder. And I was a younger man at the time, but it's a great perspective, you know, kind of just a place I never thought I'd be in, and just a little example, one of the cool things we've got to do.
That's awesome. Have you, throughout your, both of your careers, have you found one specific material to be like, oh, here we go again? This period of time they use this specific material and we always get in here. Have you ever found that? Or
I don't know if I've ever found a specific material. I'd say the things we see frequently are new products without a track record, having failures in initial use because of a miscalculation in the development of the product, or a misinstallation or a misunderstanding of its intended purpose. And then I'd say the other thing we see a lot of is materials are fine, but they're used in the wrong way, installed incorrectly, or designed for a purpose they weren't intended for.
Yeah, I agree with Matt. That's certainly a lot of where the things go wrong. And I sort of think of it as the rules of three. Three things sort of have to go wrong before something catastrophic happens, and using a material the wrong way is one of those things. Maybe the only thing I'd add is that but one of the things that drives certainly the forensic engineering side of the business is deterioration, corrosion, weather, just the weather and exposure, honestly, especially in places like Chicago, Columbus, you know, the Midwest, where it freezes a lot, and we salt our roads, right? That corrodes stuff. You know, it's just the environmental side that has a lot to do with it.
And an unused building will degrade substantially faster than an occupied building. So even sort of a derelict older building that's getting used regularly will last much longer and stay alive, if you will, much longer than a building that's ultimately abandoned, even if constructed very, very well.
And
I've found trees and grass growing inside buildings before.
Does that just have to
Amazing.
do with the climate control or the
Yeah, that's part of it. So, and just even a derelict building, it's a little bit of maintenance, a little bit of activity, a little bit of cleanup. And when they're left alone, windows break, roofing starts to wear, water starts to get in, and then you'll start to see accelerated degradation. And like I said, I've walked into a room before that has 2.5 feet tall grass just across the whole room, like a farmer's field.
I have a question from the Kelly Reesbeck says, do you either of you have a structure that you think is a real wonder in terms of how it's built or for what purpose?
It's a good one, Kelly.
Yeah, it is a good one. I mean, as a designer, I've done a lot of really unique, I always sort of tended towards really unique architectural geometries and design. So I could pull out the China Pavilion, or maybe the Apple Store here in Michigan Avenue in Chicago. Looks very simple. It's 4 columns with a roof that's only 100 feet by 100 feet, but it cantilevers out both ways. Stuffed into a 1960s garage, very complex. The China Pavilion, I think I can pull a photo of that if I can share for a second.
So the China Pavilion is from 2015, and it was.
Looks like, Barb, you have to give me permission to share.
Oh, sorry about that.
You never know what I'm going to share. It's probably smart.
Right. I have to keep close tabs on that.
So probably 2 extremes, if you guys can see the screen now.
Yes, we can see the screen.
So for Expo Milano in 2015, I was part of the SGH team designing the China Pavilion, which is a very complex timber structure with very unique geometries that required us not only to understand structural design, but also all the techniques associated with fabrication and construction so they could actually build it. And probably the other extreme would be working on Trinity Church in Boston, Mass, where I was born, lived for a long time, worked for a long time. It's an H.H. Richardson building, beautiful, beautiful old building. And I have had the opportunity a number of different times in my career to basically crawl all over this thing, from the very lowest levels in the basement to the very highest levels of the turrets, and just try to figure out how it worked, how a contractor could do their work, from simple things like accessing spaces, because you have to crawl under little arches and other certain things to get in certain places, and how they could mount scaffolding onto the building to be able to keep it looking as beautiful as it does. So a wide range of things. It's been really exciting. It's part of the fun of being a structural engineer, a civil engineer, is you sort of get to be a building tour, if you will, and you get yourself into a lot of really interesting places, both from inside high buildings looking out, but also some very interesting old buildings and looking through them.
Yeah, the photos are not as good of the crawling through the abyss of buildings, right? Unfortunately, there are good photos.
Every basement, even in a famous building, is still just a basement.
Yeah, so unfortunately, there's probably more of those than there are the cool ones. That was a nice picture, man. It's some very clean-looking masonry that you had on that building. So very. That
was a fun one. It was years ago, but we mounted motorized scaffolding up on the turret. It was actually really
cool.
It was a lot of fun.
Very cool.
Great. Blake, did you?
I will add, and Barb, you asked earlier of Blake that about the exciting buildings we work on, and I guess the clarification I'd give is that all building owners think their building is important and it's exciting to them. And so while I may not always get to, or Blake may not always get to work on a Trinity Church or a nuclear reactor, owners really of almost every building type are really passionate about their buildings. That's part of what makes what we do fun.
Well, and that's why they would call in. They call you in because they put that esteem in their building. They know what's important. So that makes sense. I love asking people about home renovation stories. They will go into the home renovation and birth stories are very near and dear. So I'd love to talk a little bit more also about your time at Oakland University, if we could just backtrack that a little bit. And we did have some students registered for this, and I wondered if you had any thoughts of or advice of what you would talk to them about or give them advice
for starting their career or just engineering in general?
I would say both, but maybe just starting. What would the next steps look like for them?
I give all young folks the same advice I got and lived by. Your first job isn't your only job necessarily. You don't have to decide at 22 exactly what you want to do for the next 45 years. So don't sweat the small stuff. If you find a job that you think is interesting, take it. I worked for a very small firm for many, many years. Before joining SGH, I really enjoyed it. I learned a ton. I'm glad I'm at SGH. I always wanted to work here. It's a great opportunity. I'll finish my career here. I'm very excited about that. But when you're young, 22, 23, 24, 25, don't worry about it. Take your time, take the job you want, travel around the country, enjoy a little bit of life, and just learn, and over time, maybe at 22, you know exactly what you want to do. And if you're like me, you didn't know till you were 27, and that's okay too.
Great.
Yeah, it makes sense to me. I mean, I haven't had too many other jobs, and I sort of fell into it to start with, but I think that's right. I mean, I've seen my career within WJ evolve, and not knowing what's next, right? And you just kind of take the next thing, right? And you have an opportunity, and you just don't be afraid to go for it, I think, in general. And engineering is a good field, right? From a background sense, so there's a lot of flexibility in that. Barbara, I think we've got some questions. I'm reading, and they're getting better and better here.
Yes.
Ed, you asked me about some kind of tower, right? What did that say? It was a communications tower. So I have worked on communications towers back in my day in the United States. They weren't the 1,500 footers that are cable stayed. Actually, no, I did work on a cable stayed one. It was probably not 1,000. It probably wasn't 1,500 feet, but it was tall, and it fell down in like crumply pattern. And so the operator asked what happened, and essentially they had they was doing maintenance on this tower, and I don't have a photo, but they had left one of the cables not as tensioned as it should have been. And these, as you can tell, these things are very skinny, so they require on the cables to resist wind loads and stay stable. A storm came through that night or whatever it was, 50, 60 mile per hour winds, and caused the thing to come unstable, and it just went straight down. So I have done a few of those. These things are now usually out in space by themselves, so they they fall down more often than you think, I guess.
We do have Cynthia Calhoun had asked, has either of you worked on any of the new structures or structures on the OU campus?
I have not. I haven't. I've either been in the Northeast engineering or now I'm based in Chicago engineering. And OU's typically using more regional engineers, although I'd love to. In fact, each year, just because I'm an alumni, I'll apply to for what they call a house doctor account, which is just ongoing engineering services that are unidentified to start. And so they sort of have you pre-selected.
Great.
Yeah, and then we do that. We do that too, Matt, out of our Cleveland office. I don't know how much work we do for Ohio University, to be honest. I haven't. I mean, I think it's our collective dream, Matt and I, to work on something important there, get to come back professionally, but it hasn't happened.
Okay.
I come back every year for the capstone senior engineering reviews, and there's a couple guys I've met over the years that were younger than me, and they actually got to work on the engineering school expansion, which I thought was fascinating. It's very cool. That's
nice.
great.
Nice.
Yeah,
Good.
I was jealous.
Okay. Another question from our audience. Dave Levy says, I'd be interested to hear about any interesting or surprising assessments of engineering failures that either panelist has experienced.
Oh, I could go on forever on those, I think. I walked into a building in Massachusetts when I was younger, a bank, and they had some water intrusion. And I went down in the basement and looked up at the structural steel frame, and it was gone. There was nothing there. And the interesting thing you actually learn about materials and structures is we take a very specific view of beams and columns and footings and foundations, but there's all kinds of other materials in the building. They all work really, really hard to keep the thing up. They were working really hard to keep that one up. That was a shocking thing to see. It was just the rust had taken away everything.
Oh yeah, there's lots of fun ones on that one, and as I've said, what I call the rule of three things sort of have to go wrong for something to fall down. Matt just alluded to it. You can lose a lot and still be there. Usually you have to design it wrong. Usually there has to be deterioration, and usually some kind of event has to happen. It seems like, we are pretty conservative in our design, so usually it takes those three things, in my experience. And I don't know, back when I first started, I remember an old masonry building in central Illinois that the wall was bowing out pretty good and you could see through it. And I remember we recommended they shore that wall and clear the street. And like 3 weeks later, the thing fell down, right? Overnight or something, right? And you just think it's kind of creeping slowly. When's it going to go? And it did. So it happens. It happens. I mean, that was kind of when I was young and just starting, I was like, wow, this matters, right? our opinions here very much matter, right? Because this was something that could have hurt people. So that was a telling experience.
Wow. Oh, and another question, has either guest if either guest has a structure or a building they want to visit in person one day, or a country that has architecture the way that you really respond to and you want to visit and have not?
Well, I haven't been to Dubai. That's been on my to-do list for a while, right? Because it's sort of a Disneyland of tall building structures, right? With all the oil money and architectural license, if you will. So I'd like to go there to stand in the tallest building and do those sorts of things, and maybe swim in one of those pools on the top of the hotel or something.
Yeah, it's a tough question to answer. I've traveled a lot, actually. Part of the reason I started my career a little late was I spent time traveling around the U.S., just looking at things. Maybe the Middle East, just to see those sort of traditional old onion domes on the top of the religious facilities, just to see one of those from the inside. Yeah, I've been a lot of places, seen a lot of interesting things. I've been very lucky.
Great.
Yeah, Matt, on that note, I was nerding out, and I hadn't been to Rome before. I was in the Rome last fall or the fall before, I guess, and in the Vatican, and looking up at all those arches and domes, because there's a lot of them, right? And like, boy, those are some wide cracks. I can see them down all the way here. And then you start looking around, and there's all kinds of monitors on these things. They're monitoring the cracks growing over time. And as Matt said, there's a lot of ways structures can hold themselves together, but the force of gravity, that was just continually working and just taking, you know, obviously when an earthquake comes through Italy, that's going to affect some things and shake them and affect it. So that was interesting international place that I wanted to go. And I was probably paying too much attention to the cracks and not enough attention to the art in Vatican and other things, but that was cool.
Right.
Every time I travel with my wife, she tells me to stop looking at the construction. You know, we're going to see something else at the museum, and I'm looking at the building next door being built. But old buildings are fun. They really are like human beings. You know, as you get older, and I'm getting older, I'm 50 now. You know, you get a sore knee until you weight your other leg a little bit more. And buildings effectively do the same thing. As they lose what we call their load path due to degradation or cracking, they'll shift the load around to other parts of the building that can hold it up. They'll keep doing that until they can't do it anymore.
And then I have in the comments, have either of the panelists been to La Sagrada Familia in Barcelona? Let's see if we can.
The never finished building? No, I was there right before the pandemic in Barcelona. So yes, that was very cool, architecturally, structurally, with the various, tall columns and bracings and the interesting, cathedral look. It's such a Barcelona. Gaudi, that's the architect's name,
Yes.
right? And
Yes.
now that was a really cool structure. I highly recommend it for anyone who wants to nerd out, Matt. It's worth the visit.
That's awesome. Great. And so Matt, you said you come back every year to the Russ for
Almost, yeah. It doesn't happen every single year, but I try to get back. I really enjoyed my time at OU, and particularly with Dr. Steinberg in the engineering school, who's a huge influence on me. And so as they've done the senior designs each year, particularly when they do buildings, I'll try to get back. I've even shared some of our projects from the past. In fact, this year the students are doing a building that I designed here a couple years ago in Chicago, both in concrete and steel. So I'll be presenting that group here in the upcoming weeks about building design, structural design, how to approach design problems. Yeah, I'm looking forward to it.
Mm-hmm. That's great. And Blake, you've come back to campus quite a bit because of you were on the OUAA, correct? On the alumni?
Yeah, I've done some of the things Matt's talking about, and the sort of reviewing the senior design, which I think has been fun. I always tend to poke at the degradation issues and the deterioration issues, not so much the design, and no one ever listens to me because it's just too much too soon. But I still enjoy doing them. But to your point, yeah, no, I am involved with the High University Alumni Association and the board of directors for that organization. So I do come back. I used to come back a lot, a couple times a year, and got to meet a lot of really cool people and see the inside workings of the university, which has been a fun experience and pretty rewarding. And still have a really good friend who lives, he's a townie, if you will.
That's my retirement goal.
What does he say? He says he was born in Oblanist, and that's where he's going to end or something. I don't know how it goes, but he's not gone far. Somehow anyway, it's townie. So yeah, so I've enjoyed coming back more frequently than just once a year prior to the pandemic.
Yeah.
What's been fun for me over the last couple of years and really eye-opening, because I really only saw the engineering school through the lens of civil engineering, is I'm on Dean Way's industry advisory board, and so it brings in people from all around different industries that Ohio produces engineering for. And that's been really fascinating to learn about all the other programs within the college and the really, really interesting work that they're doing outside of just what I know as civil engineering.
Mm-hmm. Mm-hmm. Yeah, the technology it's the engineering and technology, and really the technology has grown.
Yeah, really, some really amazing programs. Excellent.
Yeah. Is there any, I have another question. Is there any, if either guest was to take us on a tour of your city, what buildings would you take us to?
I have a lot of cities. I've lived a lot of places. I'm in Chicago now. I'd obviously take you to the new Apple store on Michigan Avenue because I designed it. Willis Tower, what we all know is Sears Tower. Yeah. And we've had the opportunity to work on, about 7 or 8 different projects all over the height of that building. It's been a lot of fun. So I've been from the lowest levels of the basement to the highest floors in Willis. Some great views, fun to see, and really sort of iconic building in terms of engineering structures and the development of tall building design. And if I was in Boston, I'd absolutely take it to the Trinity Church because it's just an amazing building to be inside.
You covered all the cool buildings in Chicago. I mean, I was there for 10 years too, Matt, probably longer than you've been there. So what the heck? You know, I mean, I've got to play around some of the cool buildings in Chicago as well. And you know, I think there's a lot to be said there. The Hancock's probably one of my favorite architecturally, or the whatever it's called now. In London, London's a mishmash, right? It's of skyscrapers and 60s blocks, and you know, and then Victorian era buildings. It's more of a mishmash than Chicago. There are some cool skyscrapers here. The Shard's pretty neat, as well as what they call the Walkie-Talkie Building, and what's the other one called? There's the Cheese Grater, which is pretty neat. I mean, they all have funny names. It is Britain after all. So there are some cool ones to do here that are very expressive architecturally, and they express the structure too, rather, through the architecture, that I think are pretty neat. Probably there. And then again, the only place I lived is Chicago, and Matt kind of greedily took them all. So there you go.
Another comment, Ed Williams asks, are there any special computer or subject studies needed for forensics engineering? And I'm sure that field it's changed tremendously from the 90s and even from the early 2000s when you graduated, because technology has grown. Can you talk about any special programs that you use that?
I mean, there's tons of them, and it depends really on what you need to evaluate. I mean, sometimes a forensic investigation is pretty straightforward. It's been a material validation to the point of failure. I don't necessarily need a computer analysis, or I can just use first principles and hand calculations. And it can go all the way up to some of the most complex analyses out there with very specialized computer programs. For example, my colleagues, not me, worked on the collapse of the World Trade Centers after 9/11 due to the impact of fire, and the analyses they did on that were spectacular and incredibly complex. Figure out exactly the impact of the fire and how it grew over time, and weakened the materials and slowly brought the building down. And so there's all points in between. And so it's you can find very, very complex software to do very, very complex analyses, including the time history of something, sort of incrementally how it lived or failed. And there's more basic programs and even just basic hand calculations in Excel and MathCAD.
Yeah, I think that makes sense. And I would reinforce what Matt said about first principles. I mean, what we look for in engineers are those that have a really good grasp of physics and math, and then have a sense for how we interpret the real world through that, and can think critically about all the details. I mean, it's very fundamental engineering stuff we look for. And then if you're able to do that, you know, you're probably going to be able to figure out how to use all these toys and tools. But if you can't start with the fundamental side, those tools are kind of worthless because you don't know how to check them. So, yeah, and all kinds of engineers can be forensic engineers. So I think it's all about the fundamentals, and then thinking critically. Really, that's my opinion.
Interesting.
Yeah, the software isn't the answer necessarily. It's a tool to get to the answer. And if you don't have your inputs correct, if you don't have the critical thinking you need in the understanding of the problems, I can make a very complex model and have it be fatally flawed because I don't have the right boundary conditions, the right loads, the right materials.
Mm-hmm.
So it doesn't matter. It's really about having a really strong engineering mind to be able to use the tools appropriately and know what tool is the appropriate tool.
And maybe forensic engineering is a little different. There's not as many playbooks for forensic engineering as there are. You know, structural design has got pretty well laid out playbooks, albeit you have to go away from them for more complex structures. I suspect other engineering disciplines have kind of similar things. There's a lot of books that make your life easier about how to short circuit to the answers if you're doing straightforward things. That's just not the case in forensic engineering, right? It's more fundamental, reactive. That being said, you know, I think design is pretty hard. I'm not saying that design is easier, because I don't think design is easier. Design, you have a million possibilities in one, and you can spend your time spinning your wheels and not go any direction in design, I feel. And I think they're both challenging, I guess is what I want to say.
Yeah, I very much enjoy getting forensic engineers to help out on design problems every once in a while, because they want to have parameters bound for them to be able to solve the design problem. Design's a blank page. There's a vision of what somebody wants something to look like, and we have to figure out how to get there.
Yep.
Interesting. I have Gary asks, what is the most challenging structural material you have worked with during your career?
I mean, I could say something like carbon fiber because I've worked with it and it's new and it's interesting, it's strong and it's lightweight. But I'm gonna say concrete, to be honest, because unlike steel and other materials, it's like an angel food cake. There's all kinds of different parts that make up concrete, and it's not so perfect that you always understand exactly what strength it's going to have, what stiffness, because it changes over time. It creeps over time, which means under sustained load, it sort of deflects more and more and more. So when you're designing in concrete for a new project, for example, you're not just looking at how does it deflect on day one under the design loads, but how does it change over time, and how does that load redistribution affect the building? It's susceptible to a lot of different sort of corrosion mechanisms. And so how it's maintained has a huge influence on how it performs long term. And so it's a material that just always takes thinking from the very conception of using it as a material on your projects all the way through its useful life in a building.
Yep, I'm going to go old school as well and say something like masonry. Masonry is kind of similar in that it's discretized chunks of like concrete and clay and other things that belies easy ways to analyze it. So it's more about how's it looking like it's reacting, and not so much how do you calculate how it's reacting. So yeah, I would go with that. I think it's a hard material. I might also mention glass. We do a lot with glass, and glass is finicky. Right, and that Apple store that Matt designed, I was going by the other day and had some big cracks in it. And I don't think it was the strengthened light of glass, but it had some big cracks in it. And that's because something weird was probably going on that was unanticipated or something. I have no idea. Matt and I'll probably get on this later, but I think glass is finicky. I don't know, Matt, what you think, but it's finicky.
I agree 100%. I'm not a glass expert by any stretch of the imagination, but I've been exposed to it a lot in projects like the Apple Store and others. And yeah, it's unique because the manufacturing process has a huge influence on how it performs, and not all glass is made the same. And it's the same for all materials. Every material is made a little bit differently. There's standards and guides, but as people and product manufacturers are always pushing the limits, they're trying something different. So yeah, glass can break just because it's got a small inclusion in it. Nickel sulfide, something like that, they'll just cause it to spontaneously explode in service.
I have a couple more questions still coming in. If you could get the keys to any building in Athens, which one would you want to explore?
The pub, for non-engineering reasons.
Okay, how did you expect us to respond to that? Like, you'd like to go to the old courthouse to see what's written on the inside of the walls? No, I'm going to go with Matt. I would
very altruistic.
Probably.
Great.
I would actually. I don't know. The rafters of the convo, I think, would be kind of cool. I believe they hung that. Didn't they? They hung a scoreboard several years ago from the middle, and I think there was probably an evaluation and possibly a strengthening that was done. I was not involved in it, but that would have been a cool project, I think.
The ridges.
I mean, I suspect the expected answer would be the ridges, right? Because it's an older building, it's unique, it's got all the stories about being haunted.
Yes.
It's got
no, that's a good point. I'd forgotten about the ridges.
Yeah. It's being used.
It was just a scary place on the hill when I was in school.
Right. I have another comment. Let's see. We're talking about specific structures, and they wonder if either or both of you have visited Bishop's Castle in Colorado. Built over time, 60 years, by one man using largely resources from the San Isabel National Forest. Have either of you? I've not an image.
No, I was married in Colorado. I've been all over that state. I haven't been there. I'll have to put it on my list.
Okay.
Well, neither me. Sounds like it feels like a gentleman rolling or lady rolling a boulder up a hill to build that. I don't know. I've never heard of that.
Okay, great. I'll have to check that out. And I think I don't have any other questions, and none coming in from the audience. Do you have anything you'd like to touch that we haven't touched on in this time? We've had some great questions. And here
Really good
is,
ones.
Yeah, this thing looks like a
there you go. The
kind
link
of
is
like a fairyland castle of some sort. It's very cool.
I'm just looking at it now.
Very neat.
Most everything
No, I
I
haven't
say
been
about
there.
OU is gonna be well received, because I think most of the people on the call are probably from OU and love it as much as I do.
I think so. Yeah, I think everyone here is. So,
It was the first university my dad and I visited during college an application process, and I never went and looked at another one.
and you were from Boston, you said, Matt. So
Yeah, Northeast. At the time I was living in New Jersey. I've lived everywhere in the Northeast, but yeah, we drove out one spring weekend and came into down the exit from the highway by the OU Inn, drove up Richland Ave, went down Court Street. Saturday afternoon, it was sunny and gorgeous, and drove around the campus. That was it. I was in. I never left.
Wow. Blake, what about you? Where are you from? Are you from Ohio originally?
Yeah, I'm from Ohio. And as I've told everyone, there's two parts to Ohio. There's Cleveland and there's not Cleveland. And I'm from not Cleveland. Is the way I feel about it. Nothing wrong with Cleveland. In fact, most of my friends are from Cleveland. Central Ohio, Springfield, between Dayton and Columbus, a couple hours from Athens. And I went to a few other places. But for similar reasons, I didn't go to many after I went to Athens. Yep, totally. And I always thought that it was a great overall experience. I think a lot of ways we think about Ohio University, right, as a great overall experience educationally and personally and all these things. And, I'm going to be perfectly honest here. There are places that are better academically for specific things, and we all know that, right? But I think holistically, I'm really happy with my decision.
Yeah, there's
As
not
you
a better
probably are.
college experience. Yeah, I agree. There's probably a better engineering school out there I could have gone to, but for the whole package of college experience, friends, the beautiful campus, the surrounding area for mountain biking and hiking and hanging out, you just can't beat it.
Right. That's great. I do have another question. Is there a preservation project that you really enjoyed working on? Really, really?
I like all of them, and I've been very lucky working at SGH because I've been able to work with a lot of our enclosure colleagues and materialist experts on the First Church of Christ the Scientist in Boston, the Trinity Church, the New York State Capitol, some support for our colleagues in DC and some of the nice buildings down there. Like I said, I mean, frankly, some of the Sears Tower here, I consider that an historic building. It's well known. And then there's smaller, just lesser known buildings, and I find those equally valuable. We spent the better part of the last 2 years working on a retail complex in Illinois here called the HIP. It's 1950s, 60s, and 70s era concrete. The same family that developed it originally still owns it. They're very passionate about it. And just helping them modernize their building was a ton of fun. There was no drawings. We had to go in and do visual observations. We had to do some non-destructive testing, so sort of x-raying the building to figure out sort of underlying construction. And then some destructive testing to corroborate what we found non-destructively and visually to establish material strengths, the layout of the framing systems, the reinforcement patterns, and then use all that information to make modifications to it, cut big holes in it, tear down parts of the facade, add new construction to it. It was really quite surgical to do what looks on the outside like a pretty simple modification to a building to make it more inviting to the public.
Wow.
So really when an owner's passionate about their building, the whole team's passionate about the process, that's really what makes it fun. It's less for me about whether it's a famous building or an historic building or a well-known building. I mean, that's fun. It's great. It's cool. It's good cocktail party fodder, but it's just when people are really passionate about what they own and how they want to extend the life of that building.
Blake, do you have any project that really springs to mind?
I wasn't going to answer because preservation, I haven't, in the traditional thoughts of preservation, I haven't gotten deep into any projects like the Trinity Church Matt was saying. I mean, I've helped understand and evaluate and repair structures throughout Chicago in some basic ways of, taking away deteriorated components inside masonry and addressing issues in curtain walls and glass, but nothing that I would call historic preservation necessarily. All kind of preservation, but not in the really cool old structure way. I mean, our company does a lot of that. I myself haven't done a lot.
Okay. And Linda Berman asks, how many colleagues are in your companies? Like, I know that you have many offices. Each of the companies has many offices, but roughly.
SGH is about 650.
Okay.
Yeah, SGH is about 650 employees, East Coast, West Coast, and then the Midwest in Chicago and Houston.
Great.
Yeah, we're about the same size, around 650. WJ is about 650, and spread out 25 offices in the United States and an office in London, which I'm sitting in. And, you know, for those in the call, SGH and WJ are sort of direct competitors. And, you know, we do a lot of the same things. We're two of the largest companies in the niche of structural and architectural forensic engineering. So it's been nice to getting to know Matt a little more through this process. And I always make fun of him because I assume you're still on 135 South LaSalle, a building we work on preserving the facade to. And as soon as I find your window, we're going to be leaving you a message. So.
Yeah, I'm sure. No, I know you guys do. It's funny. And we've worked for that same building owner, but on other buildings.
Yeah.
And I think our firms are just about the same age. We're both firms founded in the 1950s.
Mm-hmm.
Yep.
Right.
Pretty similar.
Yeah,
I think there's some business structures that are different, but like the kind of work and the age and, you know, pretty similar, I think.
I have another.
You guys should come to Europe. There's somewhat wide open spaces here. Kind of.
A little more work.
Different approaches to, yeah, different practices here for, well, the approach to forensic engineering is more of a mixed, more entities come into play here than the United States, where we seem to have SGHs and WJs and others that kind of a one-stop shop. So it's an interesting difference.
I do another question because you both talked about concrete and masonry. Gary wonders if you have either developed methods to prolong the life of buildings constructed of concrete and masonry to actually, you know.
Oh yeah, yeah. The industry is well developed in that regard. It really comes down to catching it in time. There's different approaches, right? Some owners sort of band-aid every year. They do the bare minimum to try to keep the building ticking along. And that's usually a recipe for long-term disaster. Maybe it's 5, 10, 15, 20 years, you never know. But a lot of owners, and particularly owners that will hire a WJ or an SGH, are a little bit more proactive, and they want to do a detailed assessment of their building, understand their risks, and do some capital planning so they can prepare appropriately and financially to extend the life of their building. And then, you know, within concrete, there's all kinds of things you can do, from coatings to localized demolition and repair. And masonry is not dissimilar, or is similar. And you know, even with I mentioned carbon fiber earlier. If you need to strengthen a building, either sort of vertical loads or lateral loads, there's all kinds of topical applications of carbon fiber and other elements that you can use to add tensile strength or shear resistance to the elements of a building.
Yeah, all makes sense. I think that's right. I mean, going back to the beginning of the conversation, a lot of it's just about the preventative maintenance and making sure the environment, water, isn't getting to places it shouldn't be getting. I mean, and frankly, this is 60, you know, high percentage of the issues. You know, and eventually that may lead to kind of a more interesting issue. And I think one of the questions in here that we missed was, have you worked on a project in which a failure mechanism has baffled you? I don't think baffled. I think I've ever been in a project where baffled. I think we've gotten 80% of the way and just couldn't figure out the 20%. And we just decided that, you know, we're never going to figure it out. We're going to stop. I think, yeah, I've gotten there. I don't know about Matt, about you, but that's been my experience.
Yeah, I mean, unless it's explicitly obvious when you sort of get on site or out to the building, I'd say maybe not baffled, but there's a process you're going to have to go through, almost like a process of elimination, to determine which mechanisms could have been the cause. It's rarely a single thing. And then you just sort of work through all the possibilities, do your research, do your investigations, do your material testing, and get to a point where you have more certainty in what may have happened.
Right.
So you go from uninformed
depends how much money you have and how big a problem, of course, right? So
yeah, and the cost benefit analysis. If the building's worth $1, they're not going to spend $1.50 to figure out the problem. short of it being historic or having some other sort of
Mhm.
some value.
Significance. Great. And one more question. When the panelists stay in hotels, do you like the higher floors or the lower floors?
Oh, higher floors. I like the view.
Yeah.
Yeah, me too. I like the higher floors. I don't know what Ron was fishing for, but I was in Mexico City a couple of years ago, and I, having lived in Chicago, it's not really earthquake country. I think there was that time it shook in Ohio once, several years ago, but and it was like it was the night, and I think I was in the toilet, and somebody came in and checked the room and left for no reason. I'm like, what just happened? And then I get out and like the light fixtures are swaying, and I'm feeling weird about myself, and come to realize they'd evacuated the building for a not a very high magnitude, but this was like 20 stories up, and I hadn't experienced that before. So I don't know. I may rethink it in earthquake zones.
Okay. Well, thank you.
I don't know if it's obvious, but I live on the 29th floor and I work on the 38th. So
So you're okay with the height.
I like the view.
Great. Well, we're kind of wrapping it up, I believe, at the end of our time. Any other quick questions to come in or anything else you'd like to say for the Bobcats out there? But I think that we've
Tell
had
everybody you can about OU and what a great experience it is.
Yeah.
I'm surprised, 20, 25 years later, that it's still sort of a Midwest regional school. It's got so many great amenities and such a great campus.
Awesome.
I can't, it's not more well known around the country, and it's affordable.
Mm-hmm.
Did the advancement group pay you for that, Matt? That was just, you and Barbara. I mean, she didn't offer me any deal.
Very smooth.
But of course that's true,
Listen,
right?
I love
don't know.
OU.
I mean,
I love Athens. I love everything about it. I love everything about my college experience.
That's great. That's great. Yeah, it's definitely
I ticked a lot of boxes when I was at OU.
And you mentioned it, but in working with the industry advisory group for the Rusk College Department of Civil Engineering, I mean, it peeves me still that it's not very well known outside of, like in Ohio, people know what it is. Honestly, you get outside of Ohio and Pittsburgh, it's not so much well known, and it puts out a lot of good engineering students and other students, of course. So it is annoying. I find that annoying. So I mean, I'm with you.
I'll work on that. Okay.
Well, that's not what I meant, but no, I mean, we all like to share with others, right? The things that we've got to enjoy. So
definitely. Okay. Well, thank you all. Thank you both so much for the time and the hundreds of questions, which were awesome. And I appreciate your time. And we'll be posting this soon, and we can all watch it again. Thank you so much.
Thank you.
Thanks, Barbara. Thanks, Matt.
Bye.
Bye, everyone.